Once we have our two loss functions, dloss and gloss, we need to define our optimizer. Keep in mind that the optimizer for the generator network needs to only update the generator's weights, not those of the discriminator. In order to make this distinction, we need to create two lists, one with the discriminator's weight and one with the generator's weights. This is where naming all of your TensorFlow variables can come in handy. We have used the D dash or D underline and G underline in order to find the values that we have already named. So G underline determines all of the weight values that we have for the generator, and the D dash or D underline will show us all of the weight values for the discriminator. So we can call all of them or put them in these tensors, underline vars, G underline vars. Next, we'll specify our two optimizers. In today's deep learning, ADAM seems to be the best SGD or stochastic gradient descent optimizer, as it utilizes adaptive learning rates and momentum. We call ADAM's minimize function and also specify the variables we wanted to update. The training loop is as following. During every iteration out of 1,000 total iterations that we have specified in the beginning of the code, there will be two updates being made, one to the discriminator and one to the generator. For the generator update, we'll feed in a random z vector to the generator and pass that output to the discriminator to obtain a probability score. This is the dg variable we specified earlier. As we remember from our loss function, the cross entropy loss gets minimized and only the generator's weights and biases get updated. We'll do the same for the discriminator update. We'll be taking a batch of images from the mnis variable we created at the beginning of the program. These will serve as the positive examples, while the images in the previous code that we had in the previous section of the code are the negative ones. Now that the training of both the generator and the discriminator is complete, we can take a look at one of the sample images that the generator has made. Remember that the generator has to give us fake images that are pretty similar to the real images or actual images that we have in the dataset. Here you can see what the generator can actually make from noisy data, because remember we gave it noisy data in the beginning in order to get a 28 times 28 picture, which is quite similar to the dataset that we have, the digit dataset that we have. It only receives noise and is able to give us an image which is kind of similar to the training data set. We can increase the number of the iterations in order to have more accurate image at the end. Some other hyperparameters that we can play with in order to get more and more accurate images at the end. So that's great. We are done with the implementation of the GANs using TensorFlow library. I hope you could learn the basics of designing a simple GANs network.